Chapter 5.2, exercise 11 through 18. This section 5.2 has to do with verifying trigonometric identities, and we're going to use trigonometric identities to verify trigonometric identities. So, in this case, we might be tempted to take this tangent theta and rewrite this tangent theta in terms of sine and cosine. But what I think is going to happen here is we're going to be able to simplify easier just using this as a common denominator between these two terms. So let's go ahead and work that out. We're going to have this 1 over 1 minus tangent squared theta is going to be 1 over 1 minus tangent squared theta. And I'm going to put that in parentheses. And we're going to define a common denominator. When we multiply these two denominators together, we're going to multiply this first term by this value here, 1 minus cotangent squared theta over 1 minus cotangent squared theta. Okay, and then we're going to add, we take this 1 over 1 minus cotangent squared theta, and then we're going to multiply this expression by 1 minus tangent squared theta over 1 minus tangent squared theta. And so now we have a common denominator, and let's go ahead and employ that, write this as a common denominator. What we're going to have in the numerator is 1, and then it's going to be 1 times 1, and then 1 times negative cotangent squared theta. We're going to have 1 minus cotangent squared theta. And here, this next term in the numerator, we're going to have plus 1 times 1, so that's going to be plus 1. And then 1 times negative tangent squared theta is going to be minus tangent squared theta. And then we're going to rewrite this over our now common denominator, which is going to be quantity 1 minus tangent squared theta times quantity 1 minus cosine squared, cotangent squared theta. And that's going to be as far as we can go there for this step. Now, in the numerator here, we have these like terms of numbers. So 1 plus 1 is 2. So we're going to have 2 minus cotangent squared theta minus tangent squared theta and in the denominator we're going to multiply everything out here. We expand by multiplying out. So we have 1 times 1, which is 1. And we're going to have this negative tangent squared theta times 1, so minus tangent squared theta. Next, we're going to have this 1 times negative cotangent squared theta, so that's going to be minus cotangent squared theta. And then finally, we're going to have negative tangent squared theta times cotangent squared theta, so that's going to be minus times negative plus. We're going to have cotangent squared theta, tangent squared theta. Okay, so we have that. And we're going to be able to simplify quite a bit here, especially in the denominator. And I will show you that, because what we have is this cotangent squared theta times tangent squared theta is going to be, we can rewrite cotangent, but I'm going to do this kind of on the side here. Cotangent squared theta we can rewrite is cosine squared theta over sine squared theta. And tangent squared theta we can rewrite as sine squared theta over cosine squared theta. And what do we have here? Well, we can cancel out this equal 1. So coming back to our problem, we have in the numerator, which we're rewriting, we have 2 minus cotangent squared theta minus tangent squared theta. And we change this cotangent squared theta, tangent squared theta 1 to 1, so we're going to have 1 plus 1. So in the denominator we're going to have 2, and we're going to have minus, we're going to put these in the same order. We have minus cotangent squared theta and minus tangent squared theta. Now, are the numerators and the denominators exactly the same at this point? Yes, they are. Yes, they are. So this is equal to 1, and we bring down our 1 from on top here, equals 1. So we have verified, and then, yes, we worked it out. So nice little problem there. Next on the problem 13, we have quantity cosecant squared, cosecant theta minus cotangent theta times cosecant theta plus cotangent squared, cotangent theta equals 1. So to do this one, we're going to take, just kind of multiply these through. Let's work these out. And we're going to take cosecant theta times cosecant theta is going to be equal to cosecant squared theta. And then we're going to have negative cotangent theta cosecant theta. And then we're going to have this cotangent squared theta here times cosecant theta here. We're going to have plus cotangent theta cosecant theta. And then we're going to have, finally, minus cotangent squared theta. Okay, and we should notice, and we could have from the beginning, we have a kind of a difference in squares right here going on, where the negative cotangent squared theta cosecant squared theta cancels out the positive cotangent squared theta cotangent theta cosecant theta, and what we have left is cosecant squared theta minus cotangent squared theta, and that's supposed to be equal to 1. What we can do is we can replace, in this case, if we look at our trigonometric identity, we have cotangent squared theta plus 1 equals cosecant squared theta. So we'll replace this cosecant squared theta with cotangent theta plus 1. So what we have left is cotangent squared theta plus 1, and all we've done here is replace this cosecant squared theta, then minus cotangent squared theta. And what we have left is cotangent squared theta minus cotangent squared theta. What do we have left? We have 1. And that's going to be equal to what we started out with on the right side. Check. So there's problem number 13 worked out. Next on the problem 15, we have 1 over 1 minus sine theta plus 1 over 1 plus sine theta equals 2 secant squared theta. Well, let's go ahead and work this out and find a common denominator for this expression on the left. And so what we're going to have is 1 over 1 plus sine theta, and we're going to multiply this expression by 1 plus sine theta over 1 plus sine theta. And then we're going to add to that this 1 over 1 plus sine theta. I think I wrote something down wrong a little bit here. I'm going to clean that up. Yeah, on the left side here, let me fix that. This value here is going to be 1 minus sine squared theta. Okay. Now getting back to the right side here, we're going to multiply by quantity 1 minus sine theta over 1 minus sine theta. Okay, and that should all equal 2 secant squared theta. Let's go ahead and work this out. We have a common denominator, so we're going to have 1 plus sine theta plus 1 minus sine theta. Okay, you see that? We have this 1 times minus sine theta, and all over this common denominator of quantity 1 minus sine theta times quantity 1 plus sine theta. Okay? So the next thing we're going to do is simplify a bit. Well, you notice what we have here? We have in the numerator sine theta minus sine theta, which simplifies out. And in our denominator, let's just go ahead and write this out. We're going to have 2. That's all we have left in our numerator, isn't it? In our denominator, we have 1 times 1, which is 1. And we're going to have minus sine theta, which is 1 times negative sine theta. And then 1 times plus sine theta, so we have plus sine theta. And then finally, we're going to have negative sine theta times sine theta. So we have minus sine squared theta. And so we have sine theta, or negative sine theta plus sine theta cancel to equal 0. And we have left 2 over 1 minus sine squared theta. Okay. Now Going back to our Pythagorean identity, we have sine squared theta, I'm writing this up here at the top, plus cosine squared theta is equal to 1. So if we subtract sine squared theta from both sides of this identity, we're going to have cosine squared theta is equal to 1 minus sine squared theta. Well, how does this help us out? Well, it helps us out because we can replace this 1 minus sine squared theta in the denominator with, so you have 2 over, we replace that 1 minus sine squared theta with cosine squared theta. And we should remember, I hope, that secant theta is the reciprocal of cosine theta, or is equal to 1 over cosine theta. So we can rewrite this 2 over cosine squared theta as 2 secant squared theta, which equals what we start out with here, right? 2 secant squared theta. So 2 secant squared theta, check. Okay, so next let's go on to problem 17. And that is, we have cosecant fourth theta minus cotangent fourth theta equals 2 cotangent squared theta plus 1. So let's go ahead and just write down our basic identity that we're going to use. And I hope that's pretty apparent. Well, we could rewrite this cosecant squared theta minus cosecant fourth theta minus cotangent fourth theta as a difference of squares. So we're going to rewrite this as cosecant squared theta minus cotangent squared theta times quantity cosecant squared theta plus cotangent squared theta. Okay, so what we're going to do next with this is replace this cosecant squared theta with cotangent squared theta plus 1. Because remember the identity, cotangent squared theta plus 1 equals cosecant squared theta. So we're going to do this on the left side. And any place we see cosecant theta, we're going to replace with cotangent squared theta plus 1. So we have cotangent, make another parentheses here, cotangent squared theta plus 1 minus cotangent squared theta. And we're going to multiply this by, again, we're going to replace this cosecant squared theta with cotangent squared theta plus 1, and then add cotangent squared theta, and equals that. So we have that all in terms of cotangent now. And so multiplying, just kind of adding everything together, on this left term here, we have cotangent squared theta plus 1 minus cotangent squared theta. Well, this cotangent squared theta minus cotangent squared theta, they're going to cancel each other to equal 0. So what we have left is 1. And then what we have left here at the right is, well, we have cotangent squared theta plus cotangent squared theta plus 1. So here's cotangent squared theta. And I'll just rewrite that as 2 cotangent squared theta, right? 2 cotangent squared theta plus 1. And then we just multiply through by 1. We get 2 cotangent squared theta plus 1, which equals what we started out with. So it'd be 2 cotangent squared theta plus 1. Check. So they equal each other. Check. Good luck on your evening problems. Again, with these identities, you can try different things. And eventually you'll get something simpler. And have some patience, and you'll be all right. Good luck to you, and thanks for viewing.